Okay, we're going to talk about a number called the natural number. It's denoted by lowercase e. And you may already be familiar with this term. It's a special number like pi. Pi has a special symbol, and pi is irrational, meaning that it doesn't terminate and it doesn't repeat. So it's a non-terminating, non-repeating decimal. E is the same. It's irrational. It's called the natural number because it comes up in a lot of natural cases, situations like exponential growth. It appeared in mathematics all the time. It is you don't know about limits yet, but this is what's called a sequence, and n is integers. So as n gets larger and larger, they noticed that it converged. It didn't converge to 1 like you might think. It converged to something bigger than 1, but still finite. So they decided to give this limit a special name, and they called it the natural number. It's denoted with E because the first mathematician who devoted a lot of time to studying this limit and this number was Euler. That's Euler as in E-U-L-E-R. And so later on, people started using E to denote, this limit, and the E was in honor of Euler. So he didn't give himself, he didn't give the number this notation. It was done by others in his honor. Okay, so how do we know what E is equal to? So our calculators have that programmed in. So right there, Ln in blue above that is E. So if you want to know what E is, you type in e to the 1, because remember that E, or anything raised to the 1, is itself. So e to the 1 is just E. And so there's the number. It's 2.718281828. So this looks like it repeats, but if we were to take more digits, it is non-repeating. Okay. So what we're going to do now, I guess, is go back for a minute. So we can write E in different ways, or use E as a base and evaluate it at different things. So here's just some crazy expressions that we can practice on. And e to the 0.25. E to the 3 minus 1, 2, e to the square root of 3, and 5e to the minus 2 plus 1. Okay, so I'm going to take these to the calculator and look at how we would enter them into the calculator. Okay, so the first one is e to the square root 2. So there's e square root 2. Then we hit enter. There we go, 4.11. We have e to the pi, which pi is right there. So we get that number. Now here, I have it pi to the negative e. So there we go. Uh-oh. That wasn't what was supposed to happen. Oh, I guess I need to put in. My calculator's a little different, so I'm not used to it. So there, I'm going to have to put in a 1 because it's expecting an exponent. So there's that. The square root of e. And again, it doesn't have an exponent, so the exponent is 1. Oh, whoops. E to the 1/2. And there you see that e to the 1/2 is the same as the square root of e. And that is because the square root and the 1/2 power are the same. E to the minus 1/5. Now, if you have an older TI calculator, when you do your exponents, you may need to put them in parentheses. So, for example, if you don't get this shift up here, what you'll have to do is use parentheses to make this work. So I don't really need the parentheses because it's all in line, or because it's all in the exponent. But if you're in line with the older TI-83 calculators, then you'll have to put parentheses around your exponents. E to the 0.25. And then, so this one's a little more interesting. E cubed, and then minus 1 is big, so that means it's not in the exponent. 2 e square root of 3. And there we go. And then we have 5 e to the minus 2. And then outside, big again, plus 1. And there we go. Okay, so there's a bunch of examples of how using the calculator to evaluate expressions that have e. Okay, now since e is equal to 2 point something, I think it's 2.7 something. I can, it's bigger than 0 and it's not equal to 1, so I can use it as the base of an exponent. Okay? So now what I'm going to do is look at the function e to the x. And I'm just going to use the same x's that I did in the last video. All right, now using my calculator, I am going to find e cubed, which is 20.0855. E squared, oh, so this is e cubed. E squared, 7.3891. E to the 1. Oh, let's see. 2.7183. E to the 0. I don't have to put that in my calculator. Any non-zero number to the 0 power is 1. E to the minus 1 is, let's see, 0.3679. Oops. E to the minus 2 is 0.1353, and finally, e to the minus 3 is 0.0498. Okay. So now to graph that, I'm going to go to, well, I can go to my calculator, I guess. Oh, did I? Okay. And, whoops. All right, plug in x since I want to graph it. So e to the x, and now I graph it. And there we see our function. So it looks like the others. And we could, you know, use the table and do the dot. So finally, just a reminder that the domain of all exponential functions of the form a to the x has domain minus infinity to infinity, range of non-negative values, so that'd be 0 to infinity, and a horizontal asymptote at y equals 0. All right, so that's it for this one.